Hello everyone, I'm Nidhi Rastogi and today I'll be presenting our work on insider threat detection called DANTE. So I'll start by going over the insider threat research problem, some related concepts, description of the work, and then the experiment's results and future work. Insider threat comprises malicious activities performed by insiders such as employees, contractors, temp hires, interns, ex-employees, etc. And they already have access to internal organization information, which makes them even more challenging to handle, since a malicious insider can have the motive as well as the means to sabotage the system for personal or professional gains. So it basically continues to top the security threat list year after year, and COVID-19 has further exacerbated the situation due to the remote nature of employee work environment. VPNs have replaced LANs, and so have the security posture around the employee devices. The speed at which the pandemic has spread, IT security administrators could not succeed in planning for this change, and what this led to is the subsequent impact on the security of organizations in advance. It has therefore become easier to allow social engineering techniques to imposter an employee and gain access to internal company resources without raising an alarm. Even the federal insider threat market is on pace the federal government is on pace to surpass almost $1 billion in fiscal year 2020, according to Bloomberg Government Insider Threat Market definition. Um, so, anomaly detection is frequently used to frame an insider threat detection problem due to the nature of the data set. It is usually skewed and therefore captures more benign user behavior than malignant, and this continues to be um, an issue in insider threat detection. Any outlier from a threshold indicates an acceptable behavior, which is the anomaly, and it can be further investigated to determine the category of threat as well as the root cause of the threat. And I discuss different categories of threat in my paper. Neural networks have been used to classify and predict presence of an insider threat as well as other cybersecurity threats. Recurrent neural networks or RNNs allow persistence of information due to the presence of loops in their networks, and therefore we use these in this research. This property connects previous occurrence of information to the present ones. An example of successful usage of RNNs you might be familiar with are the usage of language models that predict next word in a sentence noted by keyboards and smartphones. Specifically, we use long short-term memory networks or LSTMs, which are common type of artificial RNNs, because they can learn long-term information because of feedback connections in their networks. They differ from standard RNNs as they have four neural network layers instead of one in the repeating module. So we focus on using logs as main data for the models, and specifically system and network logs, since they actively record changes as well as current state of IT systems and servers that can assist system admins to monitor activities and events, and performance issues and detect abnormalities occurring in any part of the network or on any endpoint. Since the information can be mined from system and network logs, is detailed, and also because it follows a time sequence. Because of these properties, they can reveal information that point towards the possibility of intrusions, abnormal activities, data theft, etc. Therefore, we utilize system logs for this reason. There is another reason that we use system log behind because of which we use system logs is that the process of log generation follows certain rules, logic, and control flows like a structured form of natural language. Since the information can be mined from system and network logs is detailed and follows a time sequence, like I mentioned before, they can reveal information that point towards the possibility of intrusions or attacks. So, since log data is available in every network organization, it obviously makes sense to use them to detect other intrusion activities. Therefore, no additional data extraction is required to implement the proposed model, which is an additional advantage. So Dante uses a natural language based model that uses system and network logs, which I'm going to be calling only logs henceforth. So these logs are used to generate sequences and create rule based patterns. It captures sequences of activities across various log data, and I'll be talking about which log data in particular. So these sequences are used to create workflows, which again I'll be describing in the future in the upcoming slides. So these workflow models are used for separate tasks that can later be used to identify anomalous patterns, and then later be classified into one of the five categories of insider threats. And these five categories are described in the paper. So the Dante deep neural network model uses workflows by modeling long short-term memory and can learn long range state over the sequence of information captured. And this information is coming from logs, which are eventually converted into workflows. So it can then learn anomalous patterns and generate alert when deviations are detected. So according to the threat model that we've envisioned, it can successfully detect only known types of anomalies from the log entries. Also, there are two principal components of Dante that I'm going to be covering in this presentation. So the first one is the RNN model, and the second one is the data ingested in the model for classifying normal and abnormal behavior among user system usage. So the log is generated by network devices, operating systems, applications distributed all across the network, while an insider can have access to one or more applications or computer devices. For the purpose of this research, we assume that the logs are stored in a secure location which is not accessible and cannot be tampered with. Um, um, and the sequence of log entries for individual users are generated are all part of the system. And an assumption that we are making here is that the log data creation and storage is secure and protected from any adversarial attack. We can also assume that despite the access levels provided to employees, where some of them own administrator level access, such as system admin, supervisors, IT managers, and executives. So they might have access to servers and code that generate log files. As individuals, they do not have the permission to modify log files or the source code, which is generating the log files. The attack that we consider in this research is the insider threat who has access to various systems at different privilege levels. So the dataset that we use was the CERT dataset, which we provided a link to that in the paper. It is a decent-sized collection of synthetic insider threat test datasets and contains both benign data from normal users as well as data from malicious actors. And also for this work, we use this dataset since it contains a rich collection of log files from emails, HTTP connections, device connections, user log on, log off, as well as an interesting set of data called the psychometric test, which is based on test results of Ocean. And it's also structured and unstructured, but we did not use the unstructured data set specifically, which is coming from the emails text for this research, or even the network connection between employees that we have generated, but that's for future work. The available data sources described in that I just talked about, while they were mostly in tabulated format, they still required pre-processing to make them suitable for ingesting in our prediction model. For example, user-specific information across different sources was collated based on the relationship with other users. Um, Log on or log off into their own personal computers and other computers, their designation hours of activity, sequences of activity across various logs, etc. For example, for a given user, computer IDs that were accessed, domain category of the website accessed, email domain category, internal or external to the organization, whether it was internal or external to the organization, etc. In our model, we also identify acceptable working hours based on rules for both weekdays, weekends, holidays. Websites were categorized based on their primary activity, whether they were job hunting websites, hacktivist websites, file sharing websites, etc. What this helped us with was it allowed for normalization and quantification of data points, which would otherwise be quite a challenge to utilize in modeling. Each user's activity was also tracked by user activity, not based on daily, weekly, or monthly activity. So what you see in front of you is the architecture of DANTE with three main components: a log key value generation from log data, log parsing, workflow construction, and anomaly detection. Um, we use LSTM, as I mentioned before, as the main neural network model to process sequences of logs and classify normal and outlier behavior in the logs. Since logs can sometimes have technical issues, um, if we talk about it in practical scenarios, it might result in delay in user event record collection or may encounter offline users. Um, um, LSTM is still ideal to be used in such scenarios, especially when the offline users are a threat. So, what you see in front of you is a table which describes the creation of log key sequences that form workflows of each user per day. So log printing source code has a finite number of print statements, as we know, and therefore can print a finite number of log keys, and we take advantage of that. So for a given set k, there are only finite set of unique log keys. And this, what you see in front of you, are just a few examples of how the key value pairs are generated and used to create a workflow. So the user ID, and then the date at which that data entry was created, and then the log shows patterns of login and log out, for example. Each of them is assigned a key, um, and so on. So we use LSTM models to detect anomalous behavior in workflows created using log key sequences. And what an input would consist would be a window W of H log keys, and an output is the log key value that comes right after W. So we use categorical cross entropy loss for training. After training is done, we can predict the output for an input using a layer of H LSTM blocks. For anomaly detection from log keys, the input is a sequence of log keys of length H from recent history, and the output is a probability distribution of all possible log key values. The training set from benign users forms the baseline. The difference between a prediction and an observed parameter value vector is measured by the mean square error, which I'm sure most of us in the audience are aware of. You can find more details about this in the paper. In this table, I summarize the number of users identified as inside a threat and the number of logs classified as threat scenarios in the paper. So S1, S2, S3, S4 are different scenarios. And these are the second column is basically the number of users that were identified under that specific malignant category of insider threat. I also mentioned the number of logs, which specifically helped us identify this anomalous behavior. So what you see in front of you is the final results of the DANTE model, where the accuracy of prediction of an insider threat was 93.29%, and the average loss was 0.23 for some 500 epochs when we ran the experiments. It took us about 2 weeks to run the experiment. And the first figure to your left shows the detection accuracy of the model, and the one to the right shows the average loss as training data set increases. So finally, what is the plan for the future? So we understand there are several shortcomings of this approach, and I'd like to discuss this at this point. A shortcoming of anomaly detection overall, generally speaking, is that the baseline has been fully modeled. That's the assumption, and hence anything outside the threshold will be considered as potential threat. Or the assumption is that the baseline model is continuously updated with new acceptable IT scenarios. The problem with this approach is that it suffers from high false positives, and therefore that results in false alarms. We are going to be exploring clustering techniques instead of anomaly detection so that we can identify various behaviors of the users without a priori knowledge of benign user behavior. The second problem we are trying to solve in the future research is to solve the problem of loops within key values, where the same value might reoccur. And the third problem we are looking into is the granularity of log key value pairs. So by that I mean that the current approach uses the smallest level of log sequence, and this might lead to overlooking new patterns by new users or who join the organization with new roles and responsibility, and hence will form a new workflow. So we'll be looking into these and a few others that we mentioned in the paper. So please take a look. I'll be happy to take questions through email, so please feel free to contact me. I should be sure to respond to any questions addressed to me related to this research or anything that you're interested in related to insider threat. I'll be happy to form collaborations or at least explore them, or even more so, just happy to discuss. Thank you very much.